All right. Hey, everybody. We are moving on to 7.2 angle relationships, and it's continued from our previous lesson. So, we're going to first start off with a little bit of vocab. Okay, and our first term that we will be going over are linear pair angles. Okay, linear pair are two angles that form a line and add up to 180 degrees. These angles are adjacent, which means that they're right next to each other. So as you guys can see in the picture to the right, X and Y angles are right next to each other. They lie on the same line. So if we were to add angle X and angle Y, that would add up to 180 degrees. Okay, our next term are supplementary angles, and these are two angles that add up to 180 degrees. These angles don't mean that they're adjacent. They could be separated kind of like in the diagram to the right. But it would be the same thing as linear pair. You would add the two angles together and they would add up to 180 degrees. Supplementary angles could also look like the diagram in the top right. And then our next term are complementary angles, and these are two angles that add up to 90 degrees. So we would add the two angles, x and y, and then set that equal to 90 degrees. And then our last term for this lesson are vertical angles, and these are opposite angles made by two intersecting lines. And what you need to know are that these two angles, x and angle y, they're equal to each other. So just to summarize, linear pair and supplementary are 180 degrees. Complementary means that they're 90 degrees. And then vertical angles means that they're equal to each other. I hope you're all taking notes because these 4 vocab words are going to be really essential to doing the examples coming up. Okay, so let's get into our first example. Okay, the problem reads, angle 1 and angle 2 are supplementary angles. If the measure of angle 1 equals 4x degrees and the measure of angle 2 equals 8x degrees, then find the measure of these angles. Okay, so first thing is let's look. We have supplementary angles, and let's look back at our definitions above. And supplementary angles means that they're 180 degrees. Okay, so going back to our problem, we know that the measure of angle 1 plus the measure of angle 2 are going to equal 180 degrees. From there, it's just substitution. So I know that 4x is angle 1 and 8x is 2. So I'm just going to substitute that in. So 4x plus 8x equals 180. Then I can combine like terms. 4x and 8x gives me a total of 12x. Equals 180 degrees. And then from there, I'm just going to divide both sides by 12. So now I know x is equal to 15. But I need you guys to be careful because the problem is saying to find the measure of the angles. It's not asking you to solve for x. So this is not our final answer, which is what a lot of you guys were doing last week. So not your final answer. You have to keep going. The problem is asking for the measure of each angle. So first thing is I need to find the measure of angle 1, which stated in the problem it was 4x, And then you need to do substitution where you take that x equals to 15 and plug it into there. So 4 times 15 is going to be 60. So the measure of angle 1 is 60 degrees. Do not forget your little degree symbol. And then our other angle, measure of angle 2, is 8x. And then again, we're going to just plug that 15 also into here. So 8 times 15, which is 120 degrees. And there's our final answer for that. Also, I want you guys to note that because these angles are supplementary, if I were to add 60 and 120, we should be getting 180 degrees. So we know we did this problem correctly. Okay, on to example 2. Angle 3 and angle 4 are complementary angles. If the measure of angle 3 is equal to x plus 24 degrees and the measure of angle 4 is equal to x degrees, then find the measure of these angles. Okay, so again, first thing is we see that we have complementary angles here. And from our definition above, we know that complementary angles add up to 90 degrees. So I know that the measure of angle 3 plus the measure of angle 4 is going to equal 90 degrees. So from there, I'm going to use substitution. So I will plug in measure of angle 3 is x plus 24 plus the measure of angle 4 is x, and that's equal to 90 degrees. Then I'll combine like terms. X and x gives me 2x. Subtract 24 to both sides. 90 minus 24 is going to be 66. And then to get x by itself, you need to divide both sides by x. And that will give us 33. Remember what I said in the previous problem? That we did not finish solving the problem with x. We've got to keep going. It tells us in the problem to find the measure of the angles. So let's start off with the measure of angle 3 is x plus 24. We're going to take that 33 and plug it in for x right there, giving us 33 plus 24. So that means the measure of angle 3 is 33 plus 24 is 57 degrees. And then we do the same with measure of angle 4. We know from the problem stated above that that's just equal to x. And we know that x is 33, so we just substitute that in. So measure of angle 4 is 33 degrees. Remember that a way you can check your work is to add the two answers. And because they are complementary angles, they should equal 90, and they do. So we got this one correct as well. Okay, we're going to do one more example similar to this style. So the problem reads, two lines intersect to form two vertical angles. If one vertical angle is 2x over 3 degrees and the other one is 90 degrees, then what is the value of x? Okay, let's note two things in this problem. The first thing is that we are dealing with vertical angles. And we know that vertical angles are equal to each other. Second thing in this problem, a little bit different than what we used to, we're actually solving for x. So in this problem, we're not solving for the angle measurement, we're actually going to be solving for x. So that's cool. So because vertical angles are equal to each other, we know that one vertical angle is 2x over 3, and the other is 90 degrees. So we're just going to set both of these equal to each other, and we're going to solve for x. So we have a fraction on the left side. We're going to multiply both sides by 3 to get rid of the 3 on the denominator, leaving us with just 2x. And we know that 90 times 3 is 270. And then we will divide both sides by 2, giving us x is equal to 135. And that's exactly what the problem asked for. It asked us to solve for the value of x. We did that, and that is it. A way that you can check your work is you know that one angle is 2x over 3, and the other one is 90. Obviously, they're vertical, so this angle right here should be 90 degrees. So you can just substitute x equals 135 into the first angle, and you should get 270 over 3, which is 90 degrees. So we know that we did that correctly. Okay, I'm going to move on to a different style of problem. I'm going to do 2 examples of this. Okay, so our problem reads find the values of x and y, and we have the diagram below. So recognize what we're actually doing in this problem. We're finding the values of x and y. So we are not solving for angle measurements, we're just getting x and y. We also need to identify what types of angles do we have here. So first is I'm going to look at that angle and then this angle here. So we know that here we have them right next to each other. So if we look at our definitions to the right, angles that look like this are a linear pair. So these 2 angles are a linear pair here, and we know that they add up to 180 degrees. So I can go back to my problem and write out my equation. My first angle, 24x minus 23, and my second angle, 12x minus 13. If we add them together, it equals 180 degrees by our definitions for linear pair. Are these 2 angles. Okay? From there, we basically just solve for x. So we can add our like terms, 24x and 12x gives us 36x, and then negative 23 and negative 13, that will give us negative 36, and that equals 180. And then we add 36, we get 36x is equal to 216. And then to get x by itself, we're going to divide both sides by 36, and that will be x is equal to 6. So our problem said to find the value of x and y. We've got one part of that done. We've already got x is equal to 6, and now we can move on to the second part. So now we need to find this angle here, y. And as you can see, the one across from it, that would create vertical pairs. So if you look at our diagram to the right, angles that are across from each other are vertical angles. And we've got that actually right here. So this and this angle, they create vertical angles. By our definition for vertical angles, we know that they're equal to each other. So I'm going to set the first angle, 24x minus 23, equal to the other angle, 11y. From there, we actually have a substitution because we know that x is 6. So I'm actually going to take that and just plug that into there first. So 24 times 6 minus 23 is still equal to 11y. 24 times 6 is 144. And then I can combine my like terms on the left side. 144 minus 23 gives me 121 is equal to 11y. And then to get y by itself, I would just divide both sides by 11. 121 divided by 11 is 11, and that equals y. So there is my second answer, because I also needed to solve for y, and there it is, 11 equals y, and x is equal to 6. Okay, so we're going to move on to our last example. Okay, same directions as our previous example. We're going to find the values of x and y. So that means that we're not going to be solving for angle measurements. We are actually just solving for x and just solving for y. Now, if you guys notice something here, this is angle with an x value in it. And then here we have an angle with a y value in it. So that means we can't start with those two angles first because we need to make an equation that only has one variable. So we're going to look at the two right angles in purple because they both have an x value in it. So if we look at our definitions from up above, they look like a linear pair because they're right next to each other as so. So we know that these two angles here and here, these are a linear pair. And we know that linear pairs add up to 180 degrees. So I'm going to take each angle, 25x plus 8 and 9x plus 2, and I'm going to add them together and equal to 180 degrees. From there, I'm going to start solving. So add like terms, 25x and 9x gives me 34x, and then 8 and 2 gives me 10, equals 180. Subtract 10, subtract 10. 34x is equal to 170. And then we can divide both sides by 34, giving us x is equal to 5. So as stated in the problem, values of x is going to be one part of our answer. So that's why I boxed at that. And then now we're going to move on to the second part. So we have two ways we can go about this. We can either say that these two angles here are a linear pair, exactly what we just did, or we can say that this angle here and this angle here, they're vertical angles. So let's actually just go with that. We know that vertical angles are equal. So I'm going to set each of these angles 7y plus 5, and I'm going to set it equal to 9x plus 2. Just like our previous problem, we have to do our substitution part first, plugging in that x is equal to 5. And then we can start simplifying that. Right side, 9 times 5 is 45. And then if we were to add 2 to that, we get 47 on the right side. And now we can start doing the steps to solve for y. So I'm going to subtract 5 on both the left and right side, giving me 7y is equal to 42. And then I'll divide both sides by 7, giving me y is equal to 6. So now we did the second part of the problem. We solved for y, and we got y equals to 6. And the other part is x is equal to 5. And we are done with this. So you guys will go on Google Classroom, and you guys will find your bookwork for this week, and it is 7.2. So make sure you work on that and get that done. And do not forget to check to see what the problem is asking. Are you solving for the angle or are you solving for your variables? Also, your guys' word for the week. Your magic word for the week will not be told to you in your Zoom meeting. I'm telling you now in your video. So your magic word is zebra. So there's your magic word, and it is zebra. Have a great day, everybody.